Now, having seen the characteristics of homologous series and characteristics of organic compounds generally, let us now take a look at the first homologous family or series, and that is alkanes. We shall now take a look at the features of alkanes. Alkanes are the first homologous family we will be talking about. Alkanes are said to be saturated compounds. How do we know that? Why do we say so? It is because they have single bonds between their carbon atoms. So the carbon atoms in alkanes are characterized with the possession of single bonds. And the name alkane will always end in "ane", as we can see. Alkanes, alkanes. Their name always ends with the last letters A-N-E. The first member of alkane family is called methane, as we can see, A-N-E, methane, methane, that's methane. Other members of the alkane family include ethane, propane, butane, pentane, hexane, heptane, etc. The alkanes have a general molecular formula of CnH2n plus 2, where n is greater or equal to 1. So we shall be taking a look at how to get their formulae from this general molecular formula. The first four members of alkane family, that is methane, ethane, propane, and butane, the first four members are gaseous under room temperature. But the 5th to the 17th member are liquids, and higher members are solids. These are the features of alkane family. Now, away from that, let us take a look at the alkane family as they are. From the first person, who is methane, we have the next ethane, propane, butane, pentane, hexane, and heptane. Their molecular formula is as shown on the screen. Molecular formula of methane is CH4, ethane C2H6. So as we can see, dear students, when we add CH2 to methane, it gives us the formula for ethane, who is the next member in the family of alkanes. And if we are to add CH2 to ethane, it gives us the molecular formula for the next member in that family, who is propane. Adding CH2 to propane, it gives us the next member, which is butane. And butane will give pentane when CH2 is added to butane. And it goes down to the last, which is heptane. This is just the first 7 members of the alkane family. So, having seen the molecular formula of alkane family, first 7 members of alkane family, and it is clear now that each of them differs from the next by a CH2. That is, if we are to add CH2 to the previous, we get the next. Add to the previous, we get the next. Add CH2 to the previous, we get the next. And if you are to remove CH2 from the next, you get the previous. So having seen that, let us now get to understand how to write the structural formula of any compound belonging to any homologous family. When we talk about organic compounds, of course, we are going to learn now how to write out the structural formulae and the condensed formula. So, having seen that, let us proceed. We have said that alkanes have a general molecular formula, which is CnH2n plus 2. So, if we are to know the formula, the molecular formula for methane, let's assume we are not familiar or we have not known the molecular formula for methane, and we are told that their general molecular formula is CnH2n plus 2. And we are given the hint that n is greater or equal to 1. Then, what will be the molecular formula of the first member in that family? The first member in that alkane family will be C bracket 1 H into 2 bracket 1 and then plus 2. So this gives us C times 1 is C, H, 2 times 1 is 2, plus 2 will give us 4. So this is methane. So we can see this is how the molecular formula for methane is obtained. The next member, let's assume we don't know the formula and we are told to find the second member of the alkane family. The formula of the second member. Since we are talking about the second member in the family, this is actually what will be done. We have C, 2, H, 2 bracket 2 plus 2. And this gives us C times 2 is C2, H, 2 times 2, that's 2 bracket 2 gives us 4. 4 plus 2 gives us 6. So this is ethane. And that is how to get our molecular formula. Let us take out propane. The third member will be C3, H, 2 into 3 plus 2. And this gives us C times 3 is C3, H, 2 times 3 gives us 6, plus 2 gives us 8. And this is the molecular formula for the third member of alkane family, propane. Propane. So, dear students, this is how to know the molecular formula of any given member in a given homologous series. Now we have succeeded in knowing how the molecular formula is derived. Let us proceed, therefore, to knowing how to write the structural formula and the condensed formula. So, to do that, let us take a look at this. Now, we have alkane, we have molecular formula, MF, and let us take this as a structural formula, SF, and last of all, this is a condensed formula. Condensed formula. So how do we know how to put down the structural formula and the condensed formula of a given alkane? Beginning from the first alkane we just saw, which is methane. Methane, the molecular formula for methane is CH4. Now, what will be the structural formula? It is worthy to note here that in combination, carbon atom must always have 4 bonds. That is to say, whenever carbon is going into combination, it must have 4 bonding. It is complete with 4 bonds. So, having learned that carbon must have 4 bonds, since it must have 4 bonds, the structural formula for methane is hydrogen, 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 hydrogen. This is how the structural formula for methane looks like. So we can see that the 4 hydrogens are distributed around the carbon atom. And the condensed formula for that is just as the molecular formula, CH4. Next, we'll be talking about ethane. Ethane. Let us see ethane. Ethane has a molecular formula C2H6. C2H6, because ethane must differ from methane by a CH2. So since ethane is C2H6, what will be the structural formula? There are 2 carbon atoms in ethane, and since alkanes are saturated compounds with single bond, the carbon atoms must therefore have single bond. Since the carbon atoms are having single bond, it means that if I am to say this is carbon 1 and this is carbon 2, then carbon 1 is having 1 bond, carbon 2 is also having 1 bond. That is to say, they are both sharing bonds, and they both have 1 bond each. So which means they are both looking for 3 bonds, because we said that carbon atom must have 4 bonds to it. So carbon 1 is looking for 3 more bonds. Carbon 2 is also looking for 3 more bonds. And how are we going to distribute 6 hydrogen atoms between carbon 1 and carbon 2? Since they are both looking for 3 bonds, it means 3 hydrogen each can serve them. Hydrogen, 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 and hydrogen. And this is the structural formula for ethane. What about the condensed formula? The condensed formula is going to be just like the word sound, condensed. We are trying to compress it, that is, condense the structural formula. So trying to condense it is CH3, CH3. That is to say, we are trying to compress the structural formula together. That is what we refer to as the condensed formula. So, having seen that, let us take a look at the 3rd member of the alkane family, that is propane. Propane. Propane is C3H8. Since it is C3H8, it is having 3 carbon atoms in the structure. And each of these 3 carbon atoms have single bonds between them. Let's say this is carbon 1, carbon 2, and carbon 3. If that is the case, then it implies that carbon 2 is having 2 bonds already, because carbon 2, which is at the middle, is bonded to carbon 1 and carbon 3. But carbon 1 and carbon 3 are having just 1 bond only, because carbon 1 is just bonded to carbon 2, and carbon 3 also is just bonded only to carbon 2. So carbon 1 and carbon 3 are having just 1 bond only, because they are both bonded to carbon 2, who is at the middle. But carbon 2 is having the benefit of being bonded to 2 carbon atoms. For that reason, it has 2 bonds. So it is looking for just 2 more bonds. While carbon 1 and carbon 3 will we're looking for 3 additional bonds to make themselves up. So how do we distribute 8 hydrogen atoms between 3 carbon atoms? To distribute this, therefore, we have to say carbon 2, who is at the center, needs only 2 more bonds, so we'll give it 2 hydrogens. Out of 8, we have given out 2 hydrogens. We'll be left with 6 hydrogens. So 6 hydrogens can adequately satisfy carbon 1 and carbon 3. And that is the structure for propane. This is how propane is drawn. So this is the structural formula for propane. Now, what will be the condensed formula? The condensed formula for propane will be CH3, CH2 at the middle, and at the extreme, CH3. This is the structural formula for propane. Okay, I am going to do one more for you students, and then I believe you will be strong enough to do the other. So let us look at the fourth is butane. Butane. Butane is the 4th member in Arcane family, and it's having a formula, molecular formula C4H10. So it is having 4 carbon atoms. And how will its structure look like? Just as we did for propane, let us assume this to be carbon 1, 2, 3, and 4. So it implies that carbon 2 and carbon 3 both have 2 bonds, because carbon 2 is already bonded to carbon 1 and carbon 3, so it's having 2 bonds. Carbon 3 is already bonded to carbon 2 and carbon 4, so it's having 2 bonds. But carbon 1 is only bonded to carbon 2, so it's having 1 bond. And carbon 4 is bonded to carbon 3, making it to have only 1 bond. So carbon 2 and 3 needs only 2 more bonds, while carbon 1 and carbon 4 are looking for 3 additional bonding. So how can we distribute 10 hydrogen atoms between 4 carbon atoms? Since we have the rule that all carbon atoms must have 4 bonds, then it means that carbon 2 should take 2 more bonds which it needs. Similarly, carbon 3 takes 2 more bonds which it needs. We have exhausted 4 out of 10, so we are left with 6. And that 6 hydrogen atoms can rightly be distributed between carbon 1, 3, and carbon 4, which also is giving 3 hydrogen atoms. And with this, they are all satisfied. All of them are all having 4 bonds. Carbon 1 is having 1 bond from this hydrogen. It's having 2 bonds from this hydrogen. It has 3 bonds from this hydrogen, and it's having 4 bonds from its combination with carbon 2. And similarly, the others also. Now, the condensed formula for this compound will be CH3. The condensed formula will be CH3. Let me erase that. And I have this. I have it now. CH3, CH2, CH2, and CH3. So this is the condensed formula for butane. That's the condensed formula for butane. Maybe I'm gonna just redo this so that it doesn't get the students confused. H3, good. So that is fine. That's fine. So that is the condensed formula. So having seen that, students, I want to believe now that you can proceed to doing the structural formula, pen down the structural formula and its condensed formula for pentane, hexane, and heptane. So you can go ahead to do pentane, hexane, and heptane.